All right, this is the last tutorial in this section, and I want to cover, let's see, a couple things. Let's do counting in hex to make sure you really understand how the symbology works. Then we want to go binary to hex, hexadecimal. We want to go from, let's see, hex to binary. We'll go both ways. And we need to go hex to decimal. We won't do decimal to hex. If you want to go from decimal to hex, probably the easiest way, or in my opinion, the easiest way is to go from decimal to binary and then go from binary to hex. It's kind of the whole point in dealing with hex is that there's shortcuts available. All right, so let's start out with counting in hex. All right, so I'm going to pause here and come up with some practice problems. Okay, so here's a few random problems that I think will demonstrate the points I'm trying to get across. First, so we can have something visual to look at, I'm going to write out 1 through 15, or 0 through 15 in hex. So let's see, 8, 9, and then we have A, B, C, D, E, and F. All right, so we can kind of go back and forth. So 19 plus 1, or since we're dealing with hex, I guess we could say 19 plus 1. What would that equal? All right, so, well, you have to think about it being in hex. Don't get confused and start thinking you're going to have a 0 and carry the 1, because that would be decimal. In hex, what comes after, what follows 9? Okay, A follows 9. So 19 plus 1 is simply going to be 1A. We don't have to worry about changing the number in the second position until we get to F and need to worry about the second column. All right, so 1DE plus 2. Okay, so if we're sitting at E and we're going to add 2, we're going to go to F, okay, and then we're going to have to go back to 0. So just like if you add a number to 9, or you go past 9 whenever you're doing addition, you have to carry a number. So F plus 1 is going to be 10. So we went E, we added 1, we got F. We add another, we're going to get 0, or actually we're going to get 0, 1, because we have to add a number to the second column. So we know the last number is going to be 0. We carry a 1 over the second column, just like we did it in regular math, and 1 plus D is going to equal E. So we've got an E, okay? We don't have to carry a number there, just like we would in regular math, and so we just get a 1. So 1DE plus 2 would be 1E0. Okay, let's try 180 minus 3. Okay, so if we're sitting at 0 and we have to back up 3, we would be at D. Okay, so, but the problem is we're going backwards this time, and just like you would do in regular or base 10 math, if you're going to go backwards, you're going to have to borrow from the second column. So if we go backwards 3, we would end up at D, but since we had to go back past 0, we've got to borrow 1 from the column, so we're going to get 7 for the next, 1 minus 8, and then we're going to have 1, so 1, 7, D. You can check that if you'd like by adding 3 to 17D. If you add 3 to D, you would go 1, 2, 3. You go over the 0. 1 plus F is 10, so it would be a 0, carry the 1. 0, carry the 1, so the 1 over the 7 would become 8, and you would get 180. Okay, so A plus 4, very easy. 1, 2, 3, 4. That would be E. All right, so just trying to demonstrate a little bit, trying to get you out of your head and away from base 10 and going back and thinking to those elementary principles that you learned a long time ago when dealing with simple math. All right, so I'm going to clear the board here and put up some more practice problems for the next category. Okay, 3 random small problems to go from, let's go from hex to decimal this time. Okay, if you go back and look at the slides, first step is to write the number out in long format using base 16 instead of base 10. All right, so we've got, in this case, it would be 1, times 16 to the, let me increase my font here just a little bit. 1 times 16 raised to the first plus e times 16 raised to the 0. Okay. Now let's replace the base 10 numbers with base 10 the base 16 numbers with base 10 numbers. Just to make this easy. Well, I don't have to put the numbers on top of this. Let's do. All right. So 1. Okay, we're not. 1 in base 16 is the same thing as 1 in decimal. So no, I'm going to write the numbers here. Let's just do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Space these numbers out so they line up appropriately. Okay. 1 in base 16 is 1 in base 10. Okay, so we can leave that alone. Okay. I'll just copy and paste here. Okay. But E in base 16 is 14 in base 10. So I got to replace that here. Okay. So then we've got 16 raised to the 1 is 16. So we got 1 times 16 plus 14 times 16 raised to the 0 is 1. So times 1. So we've simply got 16 plus 14, which equals 30. So 1e in base 16 is 30 in base 10. Okay, excellent. All right, so to make room, move this around a little bit. Get rid of this. Okay, let's do 14. Okay, let's make this a little harder. Let's add a number there, 314. All right, so we just need to write this out in long format using powers of 16. So that's going to be 3 times 16 raised to the 0, 1, 2, raised to the second, okay, plus 1 times 16 raised to the 0, 1, okay, plus 4 times 16 raised to the 0. Okay. In this case, we don't have any letters, so the numbers translate directly from hexadecimal to decimal. 3 is 3, 1 is 1, and 4 is 4. So we don't have to worry about that. So now we just need to figure out what these powers of 16 are. Okay. So this would be 3 times 16 to the 2, so 16 times 16 would be 256. Don't get that confused with 16 plus 16, like I do sometimes. So then we've got 1 times 16 to the 1, so that's just going to be 16, okay, plus 4 times 16 to the 0, so that's going to be 4 times 1. Okay, so we simply have 3 times 256 plus 1 times 16 plus 4 times 1. Okay, so 3 times 256 will be 768 plus 1 times 16 will just be 16 plus 4 times 1 will be 4, which would equal, let's see, 4 plus 16 would be 20, 20 plus 8, so 788. So 314 in hex would translate to 788 in decimal. Excellent. Okay, C, D is our next one. So I'm going to go ahead and get rid of the work here and make room. Pause the video and write that down if you need to. Okay, CD, another smallish number. So you need to write this out in long format. So that would be C times 16 raised to the 1 plus D times 16 raised to the 0. Okay, let's translate those numbers. C is 12, okay, D is 13. So we have 12 times 16 raised to the power of 1, be 16, plus 13 times 16 raised to the 0, which would be 1. Okay? 12 times 16 is 192, plus 13 will equal, let's see, 205, I think? Yes, all right. So CD in decimal translates to 205, excuse me, CD in hex translates to 205 in decimal. Okay, excellent. Now we're going to go back and forth between hexadecimal and binary. Okay, so I'm going to clear the board off here again, and now to go back and forth between hexadecimal and binary, we need to first write out the binary numbers from 0 to 15. Okay, and we're going to do this in groups of 4 because F, all we have to remember is that F is 1, 1, 1, 1. You know what? Actually, I'm going to pause and rearrange this so that we're in columns, not rows. Okay, so here we have a nice table, so we're just going to populate that. So the first thing we're going to do is we're going to add numbers in decimal. Okay. Oh, we're missing one column. Add that column here, or one row, excuse me. Okay. Now I'm going to add hex. Okay, now you remember it's exactly the same. Oops. It's exactly the same for the first 9 symbols. If I can do this right, there we go. Trying to rush things and it's messing me up. There we go. Then after that, we switch to letters. Okay. Let's see if we can make this a little more friendly too. Right. And finally, that's kind of bugging me. In a second, let me get everything lined up. There we go, much better. All right, now so we've got decimal here, hexadecimal here. Now let's do binary. You need to remember how to count in binary. Okay, first of all, 0, we're going to put 4 zeros. F, we're going to put 4 ones. Oh, well, hang on, let me set this to text so it'll do what I want it to. Okay. We're using 4 because to get to F, you have 4 ones. Okay, so we go all the way from 4 zeros to 4 ones. Okay, 1, if you remember, if you think back to our lonely little kittens, we use the same symbol for both decimal and hexadecimal and binary. So we just go 0, 0, 0, 1. Okay, so after you go past 1, you know we're going to need another column. Because we've only got 2 symbols in binary. So you're going to use the second column, 0, 0, 1, 0, and we're going to make the column on the far right, we're going to go from 1 to 0 because we're starting over. Just like when you go from 9 to 10, you add a 1 and you add a 0. Okay. Next, what's the next number you can go past 1, 0? It would be 1, 1. 0, 0, 1, 1. Okay. Okay, we run out of symbols again, so we're going to have to use the next position. So it's going to be 0, 1, and then we're going to make everything else zeros. Then after that, you're just going to repeat the previous 3. 1, 1, 0, 1, 1. So 0, 1, 0, 0, 0, 1, 0, 1, going back to this one. Then you're going to go 0, 1, 1, 0, and 0, 1, 1, 1. Okay, we run out of symbols. So then it just repeats by going 1, 0, 0, 0. So we change the column on the far left to 1, make everything else zeros. And then you repeat like all the previous columns. 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0. Oh, getting closer. 1, 1, 0, 1, 1, 1, 1, 0, and then finally 1, 1, 1, 1. Practice writing those out a few times. If you don't believe me that the pattern works, all you've got to do is do the conversion. You should know by now, we've done the binary to decimal, so just do a binary to decimal conversion, and you'll see that all these numbers go to the numbers in the left-hand column. Okay, so I threw a few random hex values up here. To convert these into binary, all you've got to do is go from one column to the other. Okay, assuming these are all in hex, 3 is actually 0, 0, 1, 0. So we just write out here 0, 0, 0, 0, 1, 1. All right, there you go, easy. 4, 5, 4 is 0, 1, 0, 0, 0, 1, 0, 0. And 5 is 0, 1, 0, 1. Okay, 4, 0, 1, 0, 0, 5, 0, 1, 0, 1. D, E, F, okay, D is 1, 1, 0, 1. Okay, it's right down here. E is 1, 1, 1, 0. F is 1, 1, 1, 1. And since I like things in bytes, I'm going to add 4 zeros right here. So we have 2 bytes on the screen. I like to have 2 bytes on the screen, not just a single nibble. A, B. A is 1, 0, 1, 0. B is 1, 0, 1, 1. Okay? That's it. That's all you got to do to go back between hex and binary. In fact, that's one of the reasons we use binary. You can just chart it out, and after a while, you don't even think about the chart. You can just remember B is 1, 0, 1, 1, and C is 1, 1, 0, 0, and you can just go back and forth if you need to. To go from binary to hex, it's the exact same thing. You just take the binary value, and you look in the chart, and you line up the hex values. 1, 1, 1, 1. F, E is 1, 1, 1, 0, and D is 1, 1, 0, 1. So that's all there is to it. Going from hex to decimal, going from hex to binary and binary to hex. Work through some practice problems. Make sure that you can draw this chart, and you should be good to go.